Located in Southeast Asia, Chiang Mai University, abbreviated as CMU, is a public research university which located in Chiang Mai province, the northern part of Thailand. We are the first institution of higher education in the north and the first provincial university in Thailand. Since our opening in 1964 by our royal charter granted by His Majesty King Bhumibol Adulyadej, with the three founding faculties of science, social sciences, and humanities, we have continued to augment our structure and organization in terms of premises, the range of disciplines offered, and student enrollment. Currently, CMU has 17 faculties with 107 individual departments and a graduate school. In the year 2018, the total number of enrolled students is approximately 36,000 and over 2,000 academic faculty staffs. The student-to-staff ratio is 16.9. CMU is ranked in the 104 for Asian University ranking and ranked in the range of 551 to 600 for the 2018 QS World University ranking. Chiang Mai University is an attractive place with its own lake known as Ang Keo Reservoir. Many decent facilities are available such as public Wi-Fi access, recreation and sports stadium, and online libraries throughout the university. We've provided electric campus buses which are friendly to environment to serve all students and staff in the main campus, covering the entire university. CMU has 3 campuses, which together cover about 3,500 acres of land. Suan Sak campus, which is the main campus, is located about 5 kilometers west of the city center, set against the backdrop of Doi Suthep Mountain. This campus occupies an area of 615 acres. There are 14 faculties, together with the office of the university, a graduate school, research institutes, and major facilities. A little closer to the city, the Suan Dok Medical Campus occupies an area of 110 acres. This is a health science site consisting of 5 faculties and the Maharaj Nakhon Chiang Mai Hospital, the largest teaching hospital in northern Thailand. Moreover, about 5 kilometers south of the main campus, the 864 acres of Mae Hia campus, which is the third campus, is the home to the faculties of veterinary medicine and agro-industry. The Faculty of Associated Medical Sciences is located at Suan Dok Medical Campus, which is one of the 3 campuses at Chiang Mai University. The faculty was established in 1966 as the Department of Medical Technology, Faculty of Medicine. In January 1976, it was granted a charter by the Ministry of University Affairs to become the Faculty of Associated Medical Sciences and was designated the 11th Faculty of Chiang Mai University. Our vision is to be an institution of professional excellence and to have internationally renowned research. The faculty is recognized nationally as an outstanding institution. The faculty provides high-quality educational programs in 4 health profession areas, offering a bachelor's degree, master's degree, and PhD. The faculty comprises of 4 academic departments and an AMS Clinical Service Center, which provides several services to the public and serve as a training center for AMS students. The project of establishing a Department of Radiologic Technology to serve a local demand was led by Professor Dr. Sanan Simalak. The project became the Department of Radiological Technology on the 28th of December in 1977. Subsequently, the first batch of students, which consists of 10 members, were accepted for an admission in the year 1979. Officially, it was the first school outside Bangkok and the second school of Thailand to launch radiological technology course. Today, we offer 3 programs including a Bachelor of Science in Radiological Technology, a Master of Science in Radiation Sciences, and a Doctor of Philosophy in Biomedical Science. Over a decade, the technology has played an important role to propel medical advances, particularly in medical radiation. In consequence, the demand for radiologic technologies in hospital has increased dramatically. According to this massive demand, our department has continually accelerated the production of high-quality radiologic technologies to serve the whole needs of nation. For undergraduate course, we provide both theory and practice of professional knowledge which cover in 3 areas. Diagnostic radiology. Students can access the real instruments such as X-ray, MRI, including radiographic imaging in order to improve quality of the diagnosis of various diseases. Radiation therapy. This course focuses on practical training, including the preparation of the knowledge in advanced radiotherapy technology and the accurate use of dosimetric instruments. Nuclear medicine. This course emphasizes on working safely with radiopharmaceuticals and the effective use of tools. We also provide students with all-round knowledge, especially in molecular imaging and applied science and technology, in order to produce knowledgeable radiologic technologies. Collaborations and MOUs. Our department has a collaboration with many hospitals, not only in Thailand but also abroad, to ensure that our graduates will gain diversity experiences for their future works and lives. So far, our department has collaborated with and signed Memorandum of Understanding with international universities and institutions to promote education and research with these parties. Some of the international institutions which our department has worked with are Graduate School of Human Health Sciences, Faculty of Health Sciences, Tokyo Metropolitan University, Institute of Radiation Emergency Medicine, Hirosaki University, the Faculty of Health and Social Sciences, the Hong Kong Polytechnic University, and Université de France-Comté. Moreover, our department has a lot of interdisciplinary collaboration, which are Diagnostic Imaging and Radiotherapy Program, Faculty of Allied Health Sciences, University K Bang San, Malaysia, Seoul National University Hospital, National University Health System, Singapore, Changi General Hospital, Singapore, and Radiation Science Research Institute, Kyungpook National University, Korea.
The Department of Radiologic Technology is not only focused on professional knowledge, but also moral and ethics. This is necessary to consistently improve society and the country. We encourage students to do activities so as to help cultivate to work effectively with others, volunteer to work for society and have professional ethics, including the conservation of Thailand arts and culture. For example, our department provides a community service program for underprivileged people living in Chiang Mai and in nearby province to help promote better health care. This program offers free chest X-ray checkup, which students can take action in positioning and perform the examination. We are proud of our students for their academic achievement. They had many chances to join both national and international symposiums and competition. Moreover, we offer students the exchange program for outstanding Thai as well as foreign students to establish meaningful relationships. Students within this program will perform clinical placement in foreign countries for 4 weeks or more. They do not only learn the compulsory course but also foreign language, cultures, and traditions throughout the program. Consequently, the students are prideful to be a global citizen. In addition to the bachelor's degree program, our department offers 2 graduate programs, Master of Science in Medical Radiation Science, and International Program in Doctor of Philosophy of Biomedical Science. The program were designed for the graduates who are seeking for knowledge and research skill in medical imaging, molecular imaging, dosimetry, and radiation protection. Potential thesis of students will be based on faculty expertise. The research team, we divided into 3 main groups. The first one, Magnetic Resonance Research Group. Currently, we are focusing on 4 major areas, including image reconstruction, image analysis, MR spectroscopy, and image processing. For the image reconstruction, we have developed a new reconstruction scheme which is based on the model-based framework. We address physical phenomena that have been still challenging to be solved during data acquisition, such as mean magnetic field inhomogeneity, gradient nonlinearity, EPI phase error into a single forward model, rather than considering them in each individual step. We employ the existing optimization technique, solving our linear system to obtain the artifact-free image in single step. For the image analysis and MR spectroscopy, our ongoing research is involved in a local disease, such as thalassemia. We apply a physical property of T2 star to quantify tissue ion deposition, such as in liver and heart. Another area of our interest is neuroimaging. We study the change of brain morphology and metabolites by using analysis software called FreeSurfer along with MR spectroscopy. For the image processing, we are applying the knowledge about artificial intelligence for quantitative analysis for organ tissues and quality control of MRI scanner. Our graduated students have joined international conference and symposium under the department and research grant support. We are planning to acquire a 3 Tesla MRI scanner in the near future. With this new facility, we also have a future plan for human resources. We acquire scholarship from the Ministry of Science and Technology and Chiang Mai University for our future staff to study abroad to expand our future works in MRI data acquisition, neuroimaging techniques, and analysis, and MR spectroscopy. The second group is molecular imaging cancer treatment. The molecular imaging and cancer treatment group interested in 2 major areas, consisting of radioprotective properties in radiation of the natural product and molecular imaging probes. One of our long-standing interests is the natural product possess a radioprotective properties in radiation found on Earth and in space, induce cellular and tissue damage using the cell line and mouse model. It is clear that natural product can protect radiation-induced biological damage in the cell line and mice. One of our current researches involved the investigation of the patterns of radiation-induced cellular damage in both normal cells and cancer cells. Biophysical techniques including microscopy, spectroscopies are being used to characterize the early and late response following in vitro exposure to ionized radiation. The data from researchers will have significant impact on the future development of new strategy to prevent or mitigate the acute or long-term effect of radiation on cells and tissues at risk for public health. Also, the future development of new predictive biodosimetry for exposure to radiation that will lead to accurate on outcome prediction and treatment in medical, radiotherapy, and radiological accident. Another focus of our research interest is the aging disease, osteoporosis, for improving the quality of life in elderly society. A bone mineral density test that provide a rapid and reliable diagnosis for osteoporosis. For the molecular imaging probe for imaging and treatment of aging disease research unit of molecular imaging probe, we have been interested in discovering the bioactive compound from Thai medicinal plants for preventive and therapeutic disease caused by oxidative stress and cellular aging, including cancer, cardiovascular, diabetes, and Alzheimer's. In addition, we have interest in designing the bioactive compound together with a magnetic metal and/or radioisotope as molecular imaging probe for imaging and/or therapy of all those aging disease. Our research directions are molecular imaging probes for MRI, CT, PET, SPEC, drug discovery, radioproteomics, and radiogenomics, cell-free and cell therapy, and nutraceuticals. Dosimetry and Radiation Protection Research Group. Currently, our four major interests in dosimetry and radiation protection are: first, photon and neutron measurement. Our study focuses on developing radiation measurement methods, especially photon and neutron. We are developing neutron measurement method in various neutron energies level. For example, polymer and some radiator for neutron track edge method. Moreover, we try to use dosimetric material such as natural rubber as a shielding of neutron and photon. We have several types of radiation detector, such as cadmium telluride detector, multi-channel analysis system, sodium iodide scintillating detector, Geiger-Müller counter for radiation survey. 2. Glass scintillator and radiation protection material. We are interested in developing basic structure of glass in order to use as scintillation material for measuring X-ray and gamma ray, as well as to apply use in radiation protection. In the future, we will develop our glass for radiation measurement and radiation protection in nanoparticle level. Third, environmental radon measurement. One current research interest is a study of radon. Radon concentration in Wheeling is important due to the health risks. We measure radon level in Wheeling and water in some area of Chiang Mai. Fourth, radiotherapy dosimetry. We are interested in advanced radiotherapy treatment planning, whether in IMRT or VMAT, in combined with imaging modalities such as PET-CT, MRI-CT, because target delineation is an important process which leads to effective treatment outcome. Previously, we defined the target by using PET-CT and CT images, then compare with tumor coverage and dosimetric parameters between PET-CT and CT plane in IMRT technique. In the near future, we would like to apply other modalities to help defining tumor in radiotherapy. Our alternative interest is tumor motion, according to collaboration with many radiotherapy institutes. Our study will be focused on interplay effects in various breathing patterns in advanced radiotherapy techniques such as IMRT, VMAT, or gated VMAT. Moreover, we're interested in developing method of dose verification so as to improve the accuracy to verification.